So we're on the last one. We're on the cubic. So cubic, I actually like to call my John Travolta. So it looks like this. So it comes down and swings down like that. And this point, like kind of in the middle, is called the point of inflection. So the point of inflection, what's the definition of it? If you want to see it. Point of inflection is where a point where the slope of the curve it changes. So obviously right here it changes. So the point of inflection is a point where the curve, the slope of the curve changes. Okay. So we have our cubic here. So just show you how it works. I usually like to use a table here. So it's easier to start with the positive. So 2 cubed is just 8. So 2 times 2 times 2 is 8. 1 cubed, 1 times 1 times 1 is 1. And 0 cubed is just 0. Negative 1, negative 1, negative 1, negative 1 is positive 1. Oh, sorry, negative. Put that negative 1. And then negative 2 cubed would be negative 8. So negative 2 times negative 2 times negative 2 gives you negative 8. So it just kind of swings down like that when you plot it. All right. So our point of inflection is that's where we're going to be shifting it around. So let's look at our cubic from our notes again. So look at our cubic here. So let's look at our domain and range. So our domain would be from negative infinity to positive infinity. And our range is actually from the same thing, negative infinity to positive infinity. So it just makes sense. It goes forever that way and forever that way. And it goes forever up and forever down. So you can actually just say the domain and range is just all real numbers. Okay. So we're going to look at an example here. We're going to look at that one, the one I posted for the notes. So remember, your H is going to just shift it left or right, and your K is going to just shift it up or down, and the A is going to just make it really narrow, really wide. So let's kind of go ahead and graph that. Oh, there's our, if you don't know who John Travolta is, there he is right there and Staying Alive. I usually call my cubic my John Travolta. Okay. So this is our parent graph here. Let me kind of pull it closer so you see it. So there's our parent graph, our cubic. And let's change some numbers here. So our cubic is what? Okay, here's our cubic. Remember the 5, since it's negative 5, is going to shift to the right if it was positive left. And the force is going to shift it up. Okay, so negative 5. Go ahead. Negative 5. So negative 5 is going to shift it to the right. So obviously if it was positive 5, it's shifted to the right there. So it's kind of like always opposite what's in parentheses. But, you know, you set this equal to 0 if you're having trouble with it. So on the problem, it's, let's see, negative 5. So let's change it to negative 5 there. Is it negative 5? Cubic. Negative 5. H is negative 5. Okay. All right, so K would be, what's K? K would be 4. So it's going to shift it up to 4 there. If it was negative, it would be down there. So shift up to 4. Okay. And A, what's A on here? A would be 2. So since A is 2, it's just going to get, it's going to increase really narrow the larger it gets. But if it was really small, like a fraction, it's going to increase really slowly. And if it was a negative, what would happen? It would flip to the other side. So A was 2. There you go, 2. And that's your graph.